Good morning, fellow mathematicians. Once again, it's time for
Papa Flammy's random OIAAAAA.
What the fucking hell? What a bloody awful circus show, my boys. Back at Papa Flammy's random week, as you might have noticed, due to the introduction music. And we are back with some geometry problem. I totally forgot to announce this. It's an old American math competition problem, and it consists of three little parts. So at first we have to calculate the area of x, then the combined area of y, and then the combined areas of z right here. So that's our exercise for today. And we have some information on those circular boys right here. So A and B are congruent. They have the same radius, so that means they are pretty much equivalent. They are just shifted to the left and right a little bit. So the radius of A equals to the radius of B, and this is equal to 1. And A passes through the center of B and vice versa. So that means the arc of A passes through the center of B, which is right here, and the arc of B passes through the center of A right here. And also, C and D have the centers on the intersection points of A and B. What does that mean? Well, A and B are meeting up here, so that means that's the center. I know my drawing is absolutely awful. I don't care about drawings at all. And also, the other intersection point right here is the center of D. So those are the information that we have, and we are going to work with them today. So the exercise wanted us to take a look at the sketch that I drew here and that you saw in the beginning. And there was one little information missing, to be honest. So once again, let's take a look at the sketch right here. So we had the circle C up here, and there was the center, and also we had those other circles right here. Okay. And this was A, and this was B right here. And it didn't really give us information about the radius of C right here, or where this arc of C is crossing anything. But if you take a look in the sketch, this arc of C is supposed to cross the center of A. What does that also mean if it crosses the center of A? Well, that means that the center of C and the center of A are a radius apart. But what is the radius? Well, the radius is exactly 1. So that's the same radius as for A and B. So we can conclude in the first step that all the radii, radius A equals to radius B equals to radius C equals to radius of D. D was down here somewhere. And this is equal to 1. So that was the first thing we can conclude. Okay. What are we going to do next? And that also means that C and D are congruent to A and B. So that's quite nice. So I solved this problem using an analytical way. So I placed a nice coordinate system in here. So at first, let us take a look at those two circles right here. So we have those two circles, and that's the center of A, and this right here is the center of B. And I choose a nice coordinate system where I could use sexy symmetry in the end. So I place the y-axis right here where A and B are crossing, intersecting, and I choose the x-axis right through the centers of A and B. And now we can use the formula for a circle to construct our A and B's. So don't forget, we have a radius of 1, so that means 1 squared is equal to 1 in this case, is equal to x squared plus y squared, if you want to construct a circle with the radius 1. But in my coordinate system, A and B are shifted to the left and right. So I'm going to reduce this problem to the least information that we need. I played it through with all circles and all possible scenarios at the beginning, but for simplification purposes, we are only really going to construct the circle A at the moment. So it's shifted a bit to the right, if you take a look here. How can I explain this shifting? So fix this circle A in one place and track the y-axis a few units to the left. But what are the number of units exactly? Well, where's this intersection point right here? It's right in the middle between A and B. But this right here is exactly the radius. So this right here is 1. So that means it's shifted 1/2 units, so half the radius, to the right in that case. So that means we are taking the y-axis and pushing it -1/2 units to the left, you could say. And we are going to end up with an equation for our circle A, which is going to be 1 is equal to y squared, so y stays as it is, not up and down in this case, plus x minus 1/2, but the whole thing squared. So this right here is our equation for A, and we are going to work with it now. So let's take a look at a new coordinate system once again. So this is 1/2 right here, and we are having this circle A right here. And don't forget, the intersection point right here is the center of C or D. So this right here is exactly the center. But the good thing is, thanks to our coordinate system, the center of C is at the point where x is equal to 0. So now we just have to find the y unit of A in this case, so the y coordinate of A to proceed. So if we plug in x equals to 0 in this case, so x equal to 0, we need to find the y coordinate. That also means for A that A is now going to be 1 is equal to, so this is just going to be 0, so -1/2 squared is going to be 1/4, so y squared plus 1/4. Subtracting 1/4 on both sides and then taking the square root is going to leave us with y being equal to plus minus square root of 3/2. So that's nice. So we have found two coordinates, the first one being square root of 3/2, and the second one is going to be minus square root of 3/2. And this coordinate right here corresponds to our center of D right here. So that's quite nice. So we have done a lot of things, and the cool thing is, now that we know this corresponding y coordinate for the circle C up here, we can construct our formula just like here for this C. So how would C look? So just like before, it's square root of 3/2 units up there, so fixing this in place, dragging the x-axis down, is going to leave us with a formula for C, that 1, it has a radius of 1, don't forget this, is now equal to x squared plus, and then y minus square root of 3/2, but the whole thing squared. So we have found two formulas. Our C is somewhere up here, and don't forget what our original goal was. We wanted to find out, so imagine that, the area of x right here. But due to our nice symmetry, it's also okay to find this little area down here, this little section of a circle, and taking it 2 times, because this area is equal to this area up here. And since this area is part of the circle C, we can actually calculate that. Once again, I would like to take a look at the sketch. So let's draw it again. So we have the center of C up here being at square root of 3/2, and it looks something like this. And this right here is x/2, so half the area of x. And what my initial thought was, this right here has a length of 1. And also, this radius, we can connect this right here, is also equal to 1. So that means we are dealing with an equilateral triangle here. And my initial thought was, if I take half of the circle, so taking just a semicircle, that would mean that those two areas are indeed equal. So that's the definition of a semicircle. It's half a circle. And if we could divide this area into 3 equal pieces, that means 3 equilateral triangles, because this right here is also the radius. It has a length of 1. Same thing here, radius of 1. So that means if we could just show that this right here is also 1, and this length right here is also 1, then that means we can divide this circle into 6 pizza slices, you could say. And, well, a pizza slice also includes information about the area of this equilateral triangle, plus x over 2 in this case. So that was my initial thought. So why not find out the x coordinate for c at the y coordinate square root of 3 over 2. So I hope you can see where this thought process came from. So let's plug into this equation, y equals to square root of 3 over 2. What are we going to end up with? Well, this is going to cancel out to 0. So 1 is equal to x squared is equivalent to saying x is equal to plus minus square root of 1, which is just 1. So that means this right here, this x coordinate, is corresponding to 2 points. So the first one is positive 1. I'm going to call it p plus, for example. And this one is another point. This is p minus. So we have 2 points, p plus and minus, being equal to, so we have our x coordinate, plus minus 1, and also our y coordinate, which is square root of 3 over 2. And here's some nice symmetry into play. So this length right here is equal to this length. So just because of all the symmetry. So just like I said before, now we just want to show that this length is indeed 1, so that we can get another equilateral triangle here and another one here. So that means half the circle consists of 3 equal pizza slices. That means the whole circle consists of 6 equal pizza slices. So let's go ahead and get started. There's a formula for the distance in Cartesian coordinates. So the distance between, I don't know, this point right here has the coordinates y is equal to 0, so 1/2 and 0, because this is the center of A, don't forget that. So the distance between p plus and 1/2 and 0 is defined as follows. It's just the norm in R2 in this case of, and now we have the positive branch, so 1 and square root of 3 over 2 minus 1/2 and 0. So we can evaluate this, that's quite easy. So that's the norm of 1/2 and square root of 3 over 2. And the norm is defined as the square root of those coordinates squared, you could say. So that means we have the distance being just the square root of 1/2 whole thing squared plus square root of 3 over 2 whole thing squared. This is going to evaluate to 3 over 4. This is 1 over 4. Added together is 4 over 4. This is just 1. So the distance between those 2 points is indeed 1. So what does that mean for our circle? That means our circle, just like I said before, can be divided into equal pizza slices in that case. My drawing is ugly, as usual, but that's just how it is. So that means we can find out our x over 2 pretty easily. What is the area of this whole circle in general? Well, the area of a circle is nothing but pi times r squared. But r, in this case, is just 1, so the area is pi. So that means 1/6 of the circle, so the area of 1/6 of the circle is nothing but pi over 6, and this is the area of this pizza slice. But just like I said before, a pizza slice consists of this equilateral triangle, so this is just the area of this equilateral triangle, plus the area of this little loon down there, this little circle thingy. I don't know what to say. The circle section, right? This one. And, well, the circle section is just x over 2. How to English? Can someone please make a tutorial on how to English? Because I certainly don't know how to English. So all that's really left is to find out the area right here of an equilateral triangle. And that is quite easy, to be honest. So I'm going to show you my thought process of doing this right here. You can also take your Tafelwerk, you would say in German, and just look it up. So the area of this thing right here. So we have this equilateral triangle. That means A is everywhere here. That's just some side length. But we can cut it in half, for example, so that we get a right triangle right here. Then we are taking half this thing, turn it around and place it here, so that we end up with something like this right here. And this is just a, this is going to be a square, I guess. No, it's not a square, it's just a rectangle. Never mind. So we have this right triangle here, and that's the height. and this is a over 2. A in our case is just 1. And don't forget, this right here is also a. So we can use Papa Pythagoras to calculate our h. Since h is strictly positive, we can take the positive branch of the square root. So we end up with positive square root of a over 2 squared. No, a squared, I'm sorry, minus a over 2 squared. Just like I said, a is 1 in this case, so we end up with square root of 1 minus 1 over 4. This is going to be square root of 3 over 2. But don't forget, what's the area of our rectangle in this case? The area of this rectangle, which is also just the area of this equilateral triangle, is nothing but h times 1/2 in this case. This is going to be square root of 3 over 4. So that's the area of this thing. And now we can find an expression for our x right here. So let's do this real quick. So we now know that the area of x over 2, you could say, is just x over 2. So that's the area of this little circle section, is nothing but. So we have pi over 6, and subtracting the area of this equilateral triangle, which is just square root of 3 over 4. But we want to find out the whole area of x, so that means we need to multiply both sides by 2, not equal to 0. So we end up with x just being pi over 3 minus square root of 3 over 2. And that's it for the first part. Let's move on. So the last two parts are quite straightforward, to be honest, because we've already derived all that's really needed to calculate the area of y and z in the end. So the thing is, I played this through originally when I first did this problem, and it's indeed correct. So check it for yourself that all my formulas are indeed correct. Try out some distances in those circuits and stuff like this. We are just going to do the straightforward process now. So I want you guys to take a look at y once again. So it looks like this. But what is that exactly? Well, y consists of this equilateral triangle right here. So that's the first area. And all those half moon sections right here, those lune parts you could say, have an area of x over 2. So that means we are taking this area of an equilateral triangle, adding 2 times the area of x over 2 to it, and subtracting x over 2 one time. So what does that mean? The area of y is nothing but the area of this equilateral triangle plus 2 times x over 2 minus x over 2. This right here is going to be just x over 2 in that case. So equilateral triangle plus x over 2. Here's the formula for x once again. So that means we end up with this thing right here is just square root of 3 over 4, and then adding pi over 6 in that case, I'm sorry, minus square root of 3 over 4 to it. This and that is going to cancel out, and now we have calculated the area of y. But don't forget, we need this area 2 times, because that's just the y area of C. We also have a y area of D down there. So that means our complete area is 2 times y, and that's nothing but 2 times pi over 6, which is just pi over 3. Let us continue with the last part. So we also need to calculate the area of z. And we are having this 4 times. But if you play around with all those distances and stuff like that, you are going to notice that z is indeed just y. So z and y are equivalent. That means, since z is equal to y, that also means that 4 times z is nothing but 4 times y. But what is y? Y is just pi over 6. So we are going to end up with 4 times pi over 6, which is just 2 times pi over 3. And then we are done, I guess. So this last part was quite, I don't know, easy, but it takes quite some calculations if you want to find out that those are indeed equal and stuff like this. So try it out for yourself, not going through this process, because it would take ages to do that. If you did enjoy this video, please like and subscribe and recommend me if you like. If you want to support me a bit more, link to my Patreon is in the description. I would appreciate all kinds of help. This week is a lot of effort, to be honest. And up until the next video, have flamable days. See ya! Hallo.